Howdy, this is Ed, the CNC dude from Suncoast Technical College in sunny Sarasota, Florida, where it's a frigid 68 degrees right now, so it's a cold day here in Florida, January 5th. I'm going to virtually machine my Titan 200M on here. I think I was calling a 140M mistakenly, but I installed my vise right here, and I have my material. So that's kind of like how it would be set up. Some kind of vise there. I click this here to orient the way I want it. And I'm going to bring in a machine now. So I go to simulate right here. Simulate. Installed in the machine. And the 750 UMC 750 universal 5-axis machine is my material right there. And I'm just going to, I can make it transparent, or I'm just going to show the nuts and bolts here. So we got a face mill, the tilting axis. The tilting one is the B axis. The rotating one is the C axis. So this is in the B0, C0 position right now. And I'm doing operation 1, which is the upper part of the square part. Let's simulate. Oh, pretty slow. All right, it's going to machine the top, then flip this way and make sure we have clearance here. So this would be rotated in the B90 position, I believe, and then just rotates the C. And of course, you want to be sure you have clearance moves. So in between, I could tell in the code that it goes all the way to home before it rotates again. All right, so we got all the faces, and then there's the corner radius tool right there, which is right there. So this is the end of operation 1. All right, let's flip to operation 2, which is now upside down. And I just used a different vise. This is called a self-centering vise. It's got some dovetails here. So imagine we had machined a dovetail, but we wouldn't do that on this one. We would actually be clamping on the square part. So in reality, it's probably a better simulation with the Kurt vise, because you could stick it right in the vise, clamp around the sides, and machine the rest. This will be good for simulation purposes. So I'm going to switch machines here. Right here, you go into the library here, the Big Fusion library. So I had already downloaded my simulation machines. Right here, I have a 750, UMC 750 right here, or I can do a 500. Hit select. Hit OK. That's in my setup area. And when I go to simulate the machine, I simulate the actions. This takes a second here. All right. This is the 500. Let's turn the whole machine on here. There it is. Turn it back on again. So there's a difference between selecting a machine for producing code and selecting a machine for just doing simulation. Okay. So it's starting in the tilted position. The first operation is done, and we're going to work on this side. All right, let's hit play. Whoops, a little bit fast there. This is all adaptive clearing from the side. Then it'll rotate 180 degrees. I noticed I tried the machine over here. I thought I had fixed that issue. Plus, the roughing is probably the most time consuming, and maybe some of the parallel code would be too. So So all the stuff we learned from Titan here it's all in this program. We don't want it cutting there, that's for sure. So I think that one, we got to update the boundary or the stock size. Because this size already does. We want to be cutting anywhere on the right. That's pretty much the way it would be. Tilted, and then it's going to tilt to do face mill with this tilted up. Let's just jump ahead. This takes a little bit of simulation time. Because the 3D, 3-axis stuff is a lot of code. Okay, we continue on. I had to jump over the 3D contouring section. Roughing the inside and finishing the inside. So it's roughing and contour machining. I think I missed the face mill. That's the trace one for the chamfering. And there we are right there. All right, let me put the machine off so we can look at it. Oh, I didn't get the flow, the multi-axis flow thing. It's almost complete. That's pretty much what we're looking at as far as in whatever kind of machine you're using. UMC is pretty popular now. 500 is a smaller platter than a 750. I think it's in millimeters on diameter. It's funny that Haas is all American, all US, but they still have some metric in there. Anyway, that's it for me on my virtual machining project here. And hopefully we'll get a real machine someday and we can really make these parts. Okay, talk to you later.